Hi, I'm Tim. Join me in this video as we discuss the RadioLink A560 acrobatic 3D model aircraft. Let's get to it. This video is going to be on the RadioLink A560 RC model airplane. This is the concept. The 560 comes inside this carrying case. What we're going to do is unzip it, and you'll see in the carrying case it's a very organized disassembly of the model, transmitter, charger, batteries, everything you need. You just carry this, take it out, assemble it quickly, and you can be flying 3D aerobatics. So what I will do is I'll simply take this case and I'll unzip it. Now, this is the right side up here, and this is what you have, this foam covering on the top, and this is the airplane. There are two layers. This one, a lower layer, will go through them, and everything you need is here. There's a nice little transmitter, and this is a rechargeable battery in the transmitter, 4 channels. There are 2 cell lipos here that are the correct size and balance for the airplane. This is a additional charger, and what will happen is it is all set that you can take it out. These are struts, either control horns or structural for the wings. You'll see when we put it together to allow it to be put together. This will pull out to put in the wing, and again, I'll demonstrate all that. The lower half is the wing, landing gear, tail surfaces, screwdrivers, spare parts, a charger for the LiPo batteries, extra propellers, even a little pin for the airplane. So what I'll do is I'll take all this out, and the next series of videos will be assembly of this into the airplane. And remember, you can disassemble it to put it back into this box if you want to travel with this RC model airplane. This is the instruction manual, kind of a combination instruction manual, quick start guide. Very organized. Here's the airplane. They go over the definitions, control surfaces, where everything is. Everything that's included in the kit, the fuselage sides, the wings, and just some indication of how it'll go together. Slotting in the tail surfaces. We'll show you later how we do this. And then finally, how to pack it up in the kit when you're ready to take it on travel. We can now go through some stages of the assembly. All these components come connected. So the fuselage is just one complete thing. A lot of the stabilizing rods, struts already in place. You just slot on the wings and the tail surfaces. There are some hand tightened screws that hold everything in place. That's the concept. The idea is you can assemble it, disassemble it, and carry it with you when you want to fly somewhere. Here the wing is in place. You can see those large bolt holes that will eventually hold it in place, and the top part of the fuselage slides in. You can see the prongs that screw in place that hold everything together. Here the fuselage center section is there with the locator tabs. When we flip it upside down, we can see those are the thumb screws that twist to hold everything together, both to assemble and to disassemble. Again, all the control surfaces are hinged. Same concept for the tail surfaces. These stabilizers just slot in. There's a connector for the elevators to make sure they go back and forth. The control horns are all in. It's all very well organized, and a lot of pre-building in the factory with the little hole screw shown there. And here is the twist screw in place in that plastic reinforcement. This is a completed model. The motor is assembled. The landing gear is in place. You can see the battery on the other side there, the elastics that hold on the propeller. So you saw in the previous videos we've assembled the RadioLink. It went together very well. I think it's a thought out assembly process with these various tabs here. And they use these plastic twist-on bolts to keep on the wing and for the tail assembly right here. These are struts to support the tail, and then there's other struts to support the vertical tail, and the gear just slides in. The prop is held on by the elastic. The battery fits in this slot located here, the battery that comes with it. Carbon rod to reinforce the wing, hinges already in place. Everything went together quite well. The model balances well at this point. And what we'll do now is we will connect the battery. We'll turn on the transmitter. To turn on the transmitter, you just hold down this button. And elevator up, down, rudder left, right, and the ailerons like this for 3D flight, and plenty of thrust with the motor. So everything goes together well. It's got plenty of power. The batteries are charged up. The center of gravity is balanced. So the next thing is we'll get good weather. We'll go ahead and take it for a test flight. What will happen is we'll take it for a test flight in the normal mode with these switches up here. There are different modes for aerobatic, and I have to study it. So what I want to do is just get a test flight with the regular modes on there, come back, study what the modes are for the computer, practice that a little bit. I'll do a follow-on video with the acrobatic modes to demonstrate how those work. There's a lot of engineering work online. This is your online manual content, so it goes into great detail what everything is, specifications, and there's a lot of there's two three-way switches on the transmitter that go into a whole bunch of different modes. They're not commonly used modes. You're going to have to really do some research on what they're talking about. I think the idea is the model can have some acrobatic flights kind of built in. There's various apps you can have for Android and Apple to program the system. It just goes into all this stuff here. I did not mess around with it. If you like computers and linking up and autopilot type stuff, this is an ideal model for those activities. We're at our secret test airfield. We'll see if we can give a test flight to the RadioLink A560. The model has plenty of power, there's no problem with that. I was just concerned the amount of aileron throw. I like to fly models out of the box as they came. There is just way too much aileron throw for these types of flights. I tried to be as gentle as I could on the sticks. You'll see we'll go back to the shop and we'll cut the aileron throw by about 60%. This may be okay for high 3D flight, not for test flights. As you can see by the flights in the office park, the plane with the original amount of aileron throw was just uncontrollable. I reduced the arm throw quite a bit to get less aileron throw. The plane flew okay. It had enough power, it balanced out, just wasn't enough area. So what I want to do now that I know that it is probably going to fly, I want to try it at my regular field. It's just been terrible weather until then. So we'll head out to the field to fly it once we get some good weather. But what I wanted to show you is some things that I did to try to help it fly a little bit better. So the first thing I want to show you, this is the original arm on the aileron servo. You can see how much further out the control horn was. It was this increase in arm length that provided a lot more leverage that gave the full 45+ degree aileron movement. I physically cut the arms down to make them closer into the middle. This will result with less aileron throw. I think it should be about right. The other thing is I had to spend some time fiddling around with these top switches here that are various modes. I don't even know what the modes are. They're rocker switches, front and back. I think the plane is designed to do certain aerobatic maneuvers to include hover just automatically. We can take a quick look at the instructions. They are complicated. You go online, you have to download apps, you connect with Bluetooth to your computer and this transmitter to try and get everything loaded up. It's a language I don't even understand. If you enjoy going deep into the bowels of a computer program to get an RC model to fly, this is going to be your model. What I'm trying to do is just figure out what the pure manual mode is and just fly it manually to see how it goes from then. So what I've done is, with that change in the aileron servo arm length, that's a fair amount of throw, but I think it is okay for fairly lively flight. The elevator is plenty there, and there's tons of rudder. I'm not even going to fiddle with that. And then the motor, there's absolutely plenty of thrust. The model weighs about 7 ounces, which is pretty heavy. Now, I wanted to show you what happens with some of the built-in gyros and such. If I take this, do you notice how when I move the model, the rudder is moving? You can see the rudder. As I move the model, the rudder automatically moves. That's part of whatever gyro mode is included when the rocker switch is down like that. I think forward and neutral on the left-hand one is as close as I'm going to get to manual flight. Another thing I want to show you that I did for the connection between this shortened control arm and the ailerons. This is a very common technique I use in other models. You take two pieces of music wire and you overlap them where this shrink tubing is. That way, with an arm centered, control centered, you can overlap these till it's just where you want it, shrink the heat tubing, put some glue, and that's a very quick and easy way to adjust the length. The reason I bring that up, you'll notice here on the rudder and the elevator as well, there's this little rod with a set screw here. When I originally saw it, I said, oh great, we can just adjust it by loosening that screw, moving it back and forth with a control rod. The problem is you can't do that because I tried to do that with one of them here. You can see the set screw for the control horn, but this is a carbon fiber rod. Do you see how it just kind of went into pieces when I tried to adjust to the screw? It's not music wire. This is what happens. So that, I don't understand that. So it's lightweight. What I did on the elevator, this is metal music wire. It's a simple Z-bend in the back, and I can adjust it here all I want for the servo arm. So that's just something you're going to have to think about with the kit. Also notice these arms here, these ones here are bracing for the tail surfaces. It's not a bad idea to have a model that you disassemble, you put in a box, whatever you want to go somewhere. I personally think after a few disassembly with the foam, it's going to start getting weak and loose and all that stuff, but you'll have to figure that out on your own. So that's where we are. Thank you for going through this. The next time I'll see you, will be out at the field. We'll try a flight at the field. All right, here we go with the maiden flight of the RadioLink airplane. Wish me luck. So here we go with I call it the maiden flight. It had flown before, but this is with the greatly reduced aileron throw. Again, plenty of power. I'm just kind of feeling it out, and it handles well. The model flies well. I'm keeping it low and slow so we can see it with the camera, but a very positive control feel. It handled well. It was responsive. And I think I had the ailerons about right. I'd guess maybe 3/4 of an inch up and down for these initial flights here. But it slows down. It was a good model, and I enjoyed flying it on these initial test flights. So thanks again, Albert, for doing the video work. The flight went okay. I'm satisfied with the airplane. It is a good airplane. It's responsive. It flies well. The whole key was reducing the aileron throw. You saw in the previous ones how much aileron throw. What I like to do with the reviews is fly it the way it comes out of the box, the way it's supposed to fly. And so you've got to do something to reduce the aileron throw to what we have here. But you can see everything's all kind of neat and packaged here. It's all presented pretty well. There was no need to do the center of gravity, plenty of power with the engine. It is an interesting concept where you can disassemble it and travel with the model. And it's a lot of work to figure out how to make the transmitter talk to the airplane. The adjustments that adjust a control throw that would take you 10 seconds on a regular transmitter, you're going to have to do a little bit more work. But this is where we are, and that was the flight, and thank you for watching. And thanks to my good friend Albert here, who did the video work for the maiden flight of this airplane. Thank you, Albert.
Thank you.